So today in maths we're going to be looking at 2D shape, and we're going to be looking at quadrilaterals, and I have made a little definition sheet for you. I think it's going to help if you did something similar just for reference, and I've started off and we look at what a quadrilateral is. Quadrilateral, quadri comes from Latin meaning four and lateral meaning sides. And we've got a definition here that the total angles in a quadrilateral are always equal 360. There are four vertices, so we have got four corners, and there are four sides, and there you've got an example of different quadrilateral shapes. A parallelogram, parallel being the important thing, has two pairs of parallel sides. So all the sides in a parallelogram are going to be parallel, but in pairs. So you've got one red pair here and one green pair here. Now the important fact with a parallelogram is the opposite angles in a parallelogram are equal. So if you notice here, I have put one pair as purple and one pair as blue, and they will be equal. And again, the total angles inside a parallelogram are 360 degrees because it is a quadrilateral, four-sided shape. So we've gone on to a rectangle. A rectangle has two pairs of parallel lines. I've labelled them up for you. One pair here, one pair here. We know it's got four right angles. The total is going to equal 360. And if you notice, the definition of a rectangle fits in neatly with a parallelogram. So it can be defined as a parallelogram as well. A rhombus. A rhombus. So a rhombus has four equal sides. Probably not been brilliantly drawn here, but the four sides are equal. We always think of it like as Casey says, like a square that has been turned. The opposite angles are equal. So we've got a purple one here, matching here, and the two greens here. Again, total angles in a rhombus, 360 degrees. A trapezium. Two sides are parallel. Again, the total angles equal 360. So we can see here, this side and this side are parallel. You can also have an isosceles trapezium, where yes, we have two parallel sides, here and here, but we also have two equal sides, which I've labelled in as green. Let's go in a little bit more detail there. So you can see the green sides are equal, they've got the hatch mark, and the parallel sides are the red ones. As a result of this, the angles at the base of the equal sides are equal. So, angles at the base are equal. So like an isosceles, at the ankles, the blue angles will be the same, and the yellow angles will be the same. Right, moving on to square. I've forgotten to draw it. I'm hoping you know what a square is. We'll go with, there is an imaginary square here with four equal sides, four right angles, and the sum will equal 360. The definition of a square means it will fit with a rhombus as well. So like the rectangle and the parallelogram. And our last one here, hopefully I can open up, is a kite. And that has two pairs of equal length sides next to each other. So if you look here, these two sides are equal, which makes one pair, and these two sides are equal, which makes one pair. And then the angles here will be equal, will be the same, not these ones, so it's only those ones there.